And I told you, whenever you are going to deal with windings, you are going to have these two terms called pitch and distribution factor coming. We have used them in the EMF equation of an induction motor, but without understanding what is that. But here we are having a definition for the pitch factor, or it is also called as coil span factor. So all these pitch and distribution factors are mostly they will work with induced EMF. So the pitch factor is defined by Kp equal to phasor sum of coil side EMF divided by arithmetic sum of coil side EMF. The phasor sum means including the direction and angle. Arithmetic sum means just adding. So if they found that this Kp equal to cos beta by 2, again derivation is not in your scope. Understand what is the pitch factor. Okay, the pitch factor is uh, what is the EMF in the pitch divided by full pitch. So that is the meaning. So phasor, the numerator is going to be phasor sum of coil side EMF divided by arithmetic sum. So now definitely arithmetic sum will be bigger. Phasor sum will have positive and negative sign, but arithmetic sum will always be positive and it is larger, right? So I'm going to find the pitch factor given by Kp equal to cos beta by 2. So if you are going to have a non-sinusoidal distribution, you will have something called as harmonic. Harmonic means it is the integer multiple of your frequency. Your frequency is f, right? So harmonic is going to be n into f. Harmonic is n into f, the integer multiples of your frequency. Okay, it is going to be n into f or f into n. So when you consider that, the Kpn will be, instead of beta, I'll be putting n beta by 2. So if I want to find the sixth harmonic, means put n equal to 6 here. So you get cos 6 beta by 2 equal to 0. When will cos be 0? When will cos be 0 for any angle? For which angle cos value becomes 0?
90
90.
degree.
90. So I'll be equating 6 beta by 2 to 90. So 6 beta by 2 equal 90. So beta equal to 30. So if you have this beta equal to 30, it means that you will have the sixth harmonic, the pitch factor must become 0. That is what they say here is you can choose for which harmonic your pitch factor can be 0. So you have to eliminate harmonics. Harmonics, there will be additional noise in your system. So always we need only the fundamental frequency f, and all other additional frequencies we don't require, because all these will appear as noise. So here in this pitch factor, by designing a suitable value for beta, I can eliminate all those harmonics. So if I want, here it is given sixth harmonic. If I want second harmonic, means I'll put n is equal to 2. So 2 beta by 2 equal to 90, or beta will be equal to 90 degrees. So if I choose beta equal to 90, I can eliminate second harmonic. Only first harmonic is called as your fundamental frequency. That is your required frequency. And all other harmonics are going to be integer multiples of your fundamental frequency. To see here n into beta. This n can be 2, 3, 4, 5, etc. So n is equal to 1 means it is going to be your fundamental frequency. So if you want to reduce harmonic, means you use short pitch coils, which will save copper as well as the length of the connection. So if you use short pitch coil, means you can eliminate all these effects of harmonics in your induction motor. See, இதே harmonics வந்து we say here it is not required, but இதே harmonics in electronics and communication in higher, when you see in higher semesters, these harmonics will be required in one application. So same harmonic நீங்க பாருங்க, ஒரு இடத்துல it is not required, in one place it is required. So it depends on how you use it in your application. For our induction motor, these harmonics are not required. So these harmonics will induce noise into my motor. So I want to keep my system free from noise. So I want to eliminate harmonics here. Okay. And another one is distribution factor. So distribution is how much EMF is distributed per slots. And you know that if you are having so many slots per pole and so many conductors per slot. So over conductor, what is the distribution of EMF that is given by the distribution factor KD. So KD is phasor sum of component EMF divided by arithmetic sum of component EMF. The same definition is same. பாருங்க coil side இங்க வந்து component, because we have bothered about inside each conductor what is going to be my EMF. KD, the formula is sin Q alpha by 2 by Q sin alpha by 2. So the Q வெளில கொண்டு வரணும் denominatorல, this q will be coming out. Q first numerator it is sine of q alpha by 2 entire angle divided by this q is brought outside q sine alpha by 2. So and what is q? Q is the number of knots per pole per phase. If q is very large, then alpha becomes very small. So that sine alpha by 2, I can approximate it to alpha by 2. So I will get the answer as kd equal to sine q alpha by 2 by q alpha by 2. So this approximation is when q is very large and alpha is very small. You know that when alpha is very small, sine theta is approximately equal to theta. So denominator will become alpha by 2. So the numerator is same, sine q alpha by 2 divided by q alpha by 2. And this angle q alpha is called as phase spread. All these mathematically we cannot imagine, but when you are going to do all the EMF calculation, all these have to be considered. The pitch factor and distribution factor have to be considered in the EMF equation.